Hello everyone. In this section, we are going to learn the matrix algebra. So in this section, we are going to learn the sum and difference of two matrices like A plus minus B. And then the most important part is A times B. What's the product of two matrices? And then we will learn the derivative of matrix and the integral of a matrix function. Okay, the same thing for the derivative is also for the matrix function. So let's see, it's algebra, so pretty easy. This section is just an introduction, still introduction about all the matrices. So let's take a look at the first definition. The first definition is called addition or sum of two matrices. So firstly, A and B, the two matrices are both n by n matrices. Okay, matrix. They have to have the same size, and if we want to add them, then the addition is define addition or sum. Addition of AB to be this one, and denoted by A plus B to be same size n by n matrix. So I'm just going to give you the formula here. So if A matrix is given by Aij and B is given by Bij, and then the sum A plus B is just Aij plus Bij. That means the elements of A plus B is just the sum of the corresponding elements in A and B. Okay, so we can take a look at the example. Is pretty easy. Just add corresponding elements. Example 1. So let's take a look at those two. 1, negative 1, 4, 2, negative 5, 0. This is 2 by 3. And we added another 2 by 3. Okay, the sum. And it's going to be 2 by 3 again. Same thing. And we just add the corresponding. So 1 add 1, which give us 2. And the next, we just add negative 1 add 0, which give us negative 1. Just add corresponding position elements. Next, 7, right? And 2 add negative 2, 0. Negative 5 add 2 should be negative 3, 0 plus 7, which is 7. Okay. And then let's try this exercise problem. 1, 2, 3, 4 add negative 5, negative 2, 3, 0. Okay. Please check your answer with mine. So it should be negative 4 here, 0, 6, 4. Very easy, right? And for the property, we have A plus B equals B plus A, because for the addition, we can switch the order. Okay, and the next addition is we can add A plus B first and then add C. Okay, this is the addition, the first definition, and the second definition is called scalar multiplication. Same thing, I'm going to write down the definition easily in an easy way. So let's see. We have a scalar. So here, if A is matrix given by Aij, and S is a scalar. Scalar just means constant. Same thing, right? Constant. Okay. And so as a scalar times the matrix equals what? So we use the S scalar multiple each element. So Saij. So let's take a look at example 2. So here we have matrix 2, -4, 4, 6. And let's see, 5a, scalar multiplication. Okay, scalar is 5 times a. So we use 5 times every element in the matrix A. So 5 times 2, 10. 5 times -4, -20. And the 20, 5 times 6, 30. So this is 5a. Okay, so just use the scalar times every single element. So let's see. A equals 1, 2, 5, 4. And S is, okay, just let's find -2. So S is -2 times A. -2A. Solution is this one. So it should be -2, -4, -10, -8. Right. Next example, we are going to do similar thing, but our scalar is a complex number. So let's take a look. A is 1 plus I. The element, they are not real number, they are the complex number, right? A plus bj form. So S equals 1 minus 2i. Do you know what is I, the meaning? Let's have a quick review. I means what? Means I squared is -1. Okay, it's a complex imaginary number. So let's see. We are going to use this S times A. We want to find SA. Okay. So in that case, let's write down SA equals what? We use S times every element. So 1 minus 2i multiplied by 1 plus I. 1 minus 2i multiplied I. And 2 plus 3i. 1 minus 2i. The order doesn't matter, okay, because it's a product. Next step, we just need to simplify. Right, simplify. So here I'm only going to do one because all the others, they are the same thing. So let's just do the first one, okay? So we can do here. 1 minus 2i times 1 plus I. So this equals, we use 1 times everything. So become 1 plus I. And then we use -2i times everything. So minus 2i minus 2i squared. Is that right? Okay. Next step, we just need to simplify. So I squared is 91. So here we combine those two. 1 minus I minus 2 times 91. So it should be 1 minus I plus 2. So it should be 3 minus I. So the first element, 3 minus I. The second one should be I minus 2i squared, so I plus 2. So it should be I plus 2. And we skip the third and the fourth term. So, but after we simplify, they are just like this. Okay. I'm going to give you an easy exercise. Let's try. Please find this number, this one. Okay, pretty easy, right? Let's see. The first one, 5i minus 1, 2i plus 1, and the -1, positive 1, 2i minus 4. Here's 2. Okay, so just a complex number. In the future, we may need to use this product, scalar multiplication in the future. Next definition is called subtraction. So subtraction is same as sum, because you can see it's like a minus b. We can look this as a plus 91 times b, right? So this is called subtraction. Okay, and the definition is just given by this one, aij minus bij. Okay, we skip the example, it's pretty easy. So that's subtraction. And for the properties, let's see, we have 1 times a, which is a scalar. It's like 1 times everything, definitely should be same as a. And scalar a plus b, which is sa plus sb, we can distribute the scalar. And if we have two scalars, sa plus ta, distribute the matrix. And as ta, we can combine two scalars and then multiply by the matrix A. Okay, those are properties. Next, let's take a look at definition 4. Zero matrix. The zero matrix, okay, let's see the notation. Okay, we denote this by like 0, but we write down like a capital O, the large O, and M by N. Okay, so this is the M by N matrix whose elements are all zeros. For example, if I write down 2 by 2, so this is not 0, this means zero matrix. So it should be 2 by 2 matrix and with all the elements 0, something like that. Okay. So A plus O equals same thing, because it's like 0 plus aij, right? Each term adds 0, so still equals that one. Next one, A minus A is not 0, it is 0 matrix. So for the 0 matrix, let's add something, okay? Separate with the scalar 0, number 0. So that means 0 matrix. Because it's like 2, 2, 2, 3 minus 2, 2, 2, 3. So it's not going to be 0, doesn't equal 0. That equals actually 0, 0, 0, 0, right? 0 matrix. And here, if we use scalar times A, so it's going to be a 0 matrix. 0 matrix. So this is scalar. Here is the matrix. Can you see the difference? Okay, next definition is pretty important. That is matrix product. So very important. Let's take a look. Definition 5. Okay, A is a row vector. So think about what's the row vector look like. Okay, and X is a column vector. So we can say n vector. They both has n elements. Okay, then matrix product is a 1 by 1 matrix. O is just a number. Okay, 1 by 1 is just a number. Matrix product is this one. So let's take a look. A times X. A is a row vector, so we can say A1, AN. Let's write down one more, A2. Okay, and times X. X is the column n vector, so it should be X1, X2, Xn. So product of this one equals what? Let's see. This equals a1 x1, okay, plus a2 x2 plus an xn. So you can see this is a number actually, right? So the product of a row and a column vector is going to be a row vector. Let's take going to be a number. So let's take a look at the example. A equals 2, negative 1, 3, 5. X equals to 3, 1, negative 3, 2. And be careful, when we do the product, they have to have the size, they have to, for the vector A, it has to have 4 elements and X has to have 4 elements. They have to have the same size, okay? Not exactly the same size, but same number of the elements. So let's see, A times X equals what? So going to be 2 times 3, right? 2 times 3. Negative 1 times 1 plus 3 times negative 3. 5 times 2. And just to simplify, 6 minus 1 minus 9 plus 10. And this is negative 10, 10 cancelled. So it just equals 6. This is called product. So let's see. I'm going to give you an exercise and let's just try. X equals 1, 0, negative 2, 3. A equals 5, 6, 0, 1. Find AX. Okay. Please do this by yourself and then check with my answer. So I think the number should be 5 add 0, add 0, add 3 should be 8. Okay, 8. Next, we are going to do the general product of two matrices. Okay, because in this definition, it's only the vector matrix. Next, we're going to do the general. Let's take a look. So we are going to do this one. Under definition 5, we can say this is the first case. Okay, first. The second one is going to be a matrix M by N multiplied by N by 1. Let's take a look. So M by N, A11, A12, A1N, A21, A22, A2N. So this is a general matrix, right? And M by N means we have M rows, M1, M2, Mn, and multiplied by x1, x2. So same n, can see n here. Okay, for this product, how to do this product? Okay, let's we are going to do this way. The product n by n, n by 1 is going to be m by 1. I'm going to show you why, okay? So definition is going to be like this. So right now, we look the first row as just a row vector. Like in the last definition, use this row vector multiplied by the column vector x. Okay, let's see what that equals to. So it's going to be a11 x1, a12 x2, right? And a1n xn. So this gives us a number. Is that right? It's going to be a number. So we put this in the first row. And then we use the second row multiplied by the column vector. So it's a21 x1, A2 to x2, A2 n x n. Okay, that's why this number has to be n, this number have to be n here, because we need the same number, right, of the vectors to do the multiplication. Skip the middle rows. Okay, so the last row, we are going to use the last row in the matrix A. So it's going to be like this one times that column. It's going to be am1 x1, am2 x2, amn xn. So you can see here, because for the matrix A we have m rows, so here we also have the m rows, but in each column we only have, so for this one we only have one column, because in each row there's only one number, right? So the final should be n by 1. Don't worry about the size. I'm going to talk about more about the size in the future. So now let's just see how to do the calculation. Okay, example 5. So here we have a general matrix. This is 3 by 3. Five, 92, 0. And here we have a matrix X, which is 7, 93, and 91. Let's see. AX equals what? So we can just use the definition. Now use the first row times this column. Okay, so the first number should be 2 times 7, 3 times -3, plus 91 times 91. This gives us first row. Second row, we use the second row in the matrix A multiplied by X. So it's 1 times 7, 4 times -3, 96 times 91. And the last row, so 5 times 7, 92 times 93, plus 0 times 91. Just algebra here, simplify those numbers, right? So this number should be 14, -9, and plus 1. 14 minus 8 should be 6. 14 minus 8 should be, 6. Next one should be -11, 7 minus 12, 95, 95 plus 6. 95, wait a second, -7, -12, 95, 95 plus 6 should be positive 1. You can write down one more step, like what those numbers are. Okay, so it's like 14 minus 9 add 1, 7 minus 12 add 6, and 35 plus 6. That's maybe a little bit better. Okay, just write down those one more step. So this is a multiplication. I'm going to give you one exercise and let's try. So we start from the easy one. Okay, 2 by 2 multiple by 2 by 1. Those two numbers have to be the same. Okay. Let's see, AX equals to, please try this by yourself. So here I'm going to give you another one. So here are the two solutions to the exercises problems, and you can check which answer. Next, we are going to have the third, definition, third case. So which is more general, because in the first one is like a row times a column, right? So it's like 1 by n times n by 1. And the second one is like a little bit general, n by n multiplied by n by 1. So this, the right side is still a column vector. And right now we are going to do m by n multiplied by n by p. More general, not just column vector. It's going to be a matrix, general matrix. So let's see. So we have matrix A, m by n, multiplied by B, matrix B. So it has to be in the middle, they have to have the same size. Okay, m by P. And this equals what? Now we look B as, okay, so B is kind of like n by P. So we are going to look B as made by column vectors like this way. Okay, and we do multiplication. I'm going to show you this in the example. The definition is given by this way. So we look B as like a B1, B2, and the BP, P columns, and A times B equals, and we use A times each column, okay, and AB2, ABP. And the final product of matrix is going to be M by P matrix size. Let's take a look at this in the example. It's much easier in the example. We have matrix A, 1, 4, 2, 3, 5, 7. First, let's see what's the size. 2 by 3. Okay, and for the B, we have, it has to be 3 by something, right? So 3 by 2. Let's see. 2, 3, 5, -2, 8, 4. Right now, we are going to multiply A and B together. Okay, we are going to do A and B. So we look this in this way. So the final is going to be 2 by 2. Choose the outside, those two. 2 by 2 matrix. I'm going to show you. Right now, look B made by 2 column vectors. 1, 2. And then we use matrix A times B. Okay. The first position, A11, we use the first row in A times the first column. So it's kind of like, I'm going to label this way. A11 is going to be use this column times the first row times first column. So let's write down this number. It's going to be 1 times 2, 4 times 5, 2 times 8. Then it's like in the second definition, second case, we use the matrix A times the column vector times the first column of the matrix B. So you can see it's going to be here, this number, right? It's going to be the second row of the matrix A times the first column of B. So it's 3 times 2, 5 times 5, 7 times 8. And then we use the matrix A multiplied by the second column of B, and then which give us this column here. So let's try. So it's going to be the first number, the top number should be first row in the A, so 1 times -3, 4 times -2, 2 times 4. And then last number is going to be 3 times -3, 5 times negative 2, 7 times 4. Simplify this number. Do some calculation. The first number is 38, 3, 87, 27. This is a little bit large, but don't worry. In the future, in the quiz or exam, I'm just going to give you some easy numbers. But it's just algebra, right? So you can also think this way, for a matrix A times B, we can get a matrix C, right? So for example, in this position C11, use the first row times first column. C12, use the first row times second column. So C21, second row, first column. C22, second column times second row, second column. So you can also think this way. So I think that is easier. This is easier, okay, for you to set up the position of the number. So let's try this exercise problem. Don't worry too much. I know this may be difficult at beginning, but you just need a little bit of practice. Let's take a look at this matrix. Let's do easy one. 2, 1, 0, 3. This is 2 by 2. Let's do a 2 by 3. So it's going to be 1, 2, 0, 91, 1, 2. Let's see. Those numbers are pretty easy, right? Firstly, we can write the size. Just in case if you made a mistake, we can still check our matrix here. So the product matrix should be 2 by 3. And this number is going to be first row times first column. So going to be 2 minus 1. Right, 2 minus 1. And this number, first row times second column. 2 times 2 plus 1 times 1. And the last number is going to be this is A13, first row times third column. 2 times 0 plus 1 times 2. And the second row is going to be like a second row of the matrix A. So 0 times 1 add 3 times negative 1. And 0 times 2 add 3 times 1. 0 times 0 add 3 times 2. Right? Okay. The final answer should be 2 by 3. So just simplify. 4 add 1, 5. 2, negative 3, 3, and 6. Okay, that's the exercise. Let's try one more. One, 3, 2, 4 times 2, negative 2, 0, 1, 5, 3. Firstly, please write down the size of the resulting matrix and then fill all the blanks. Let's take a look. Solution. 2 by 2, 2 by 3. The resulting should be 2 by 3. And this number should be 1 times 2 and 3 times 1 should be 5. And this number should be 1 times negative 2 and 15. Negative 2 and 15. 13. And this should be 9. This number should be 2 and 4 and 4 should be 8. This number should be negative 4 and 20, so it should be 16. this number should be 4 times 3 should be 12. Please check your answer. Okay. And last thing, just remark here. I'll just mark. For the matrix A, which is m by n times the matrix B, we can only times the matrix like same size here, n by p, and the resulting like a product is going to be m by p. So like those two numbers, m by p. Okay, we can stop here for this class.